temperature relations. That's what we'll be discussing in this lecture. So I want you to be able to list and define various attributes of microclimates. List the abiotic and biotic factors that will change a microclimate. Give a brief description of how each abiotic factor can change a microclimate. And these microclimate things are what we're doing as kind of a group activity. So define and apply the principle of allocation and give examples of how organisms may perform differently given different biotic or abiotic factors for which you'll be creating your own lizard. So temperature. Temperature is the movement of molecules in a solution, in a fluid, in a solid. Basically, how fast are the molecules moving? As we increase temperature by adding heat, we are increasing how fast the average movement of a molecule may be. Take, for example, this flower. On this flower, there is a certain population of scent molecules. So the scent molecules are going to be relatively still at about 0 degrees Celsius. But as heat is added to these scent molecules, they're going to start vibrating and moving around. And as they vibrate and move around, some of them are going to be ejected from the surface. And if they're ejected from the surface, they're going to travel through the air. If the air is warm, they're going to be vibrated and moved quicker in the air to move a farther distance. So this is the kinetic energy of molecules and how it is interacting with flower scent. As the flower warms up, it smells more. This flower is also able to track the sun and aim itself towards the sun, and that allows its enzymes to work at a better rate. Enzymes have an optimal temperature at which they're going to conduct their reactions. If you remember the introductory biology classes, you remember that there's a certain transitional state in the enzyme. There's a certain activation energy to move up to that transitional state, and that is generally from the energy of the molecules, which is heat. So as more heat is added, enzymes generally work better up to a point when enzymes are going to stop working better as they denature due to excessive temperature. There is also an intimate connection between heat and water. So as a plant warms up, it can evaporate water from its surface to cool itself down. You too, you sweat. That's how we interact our water relations with our temperature relations. We lose water, but we also lose temperature. It also has relation with precipitation. So as air is hotter, it's more able to hold water, and thus there'll be less precipitation. As air cools down, it's less able to hold water and more likely to precipitate. So physiology. This may or may not be review, so I didn't put it in the objectives, but this is generally something we should understand, is how physiology interacts with temperature. There's heat uptake and heat loss. So an example would be radiation. Not, Chernobyl, but heat radiation. So heat radiation can occur if, say, I've got a candle here. There we go. So heat radiation, I'll be able to feel the warmth of this candle because this candle is giving off a certain amount of heat and light. That light is just radiation in a different spectrum. So that's radiation. I can take up heat as this candle is giving off heat. It's radiating heat. It also is very odorous. This is a scented candle, and as the molecules in that candle heat up, it's making this room smell like a bakery. So, enough of that. There we go. So next would be convection. The movement of molecules over a surface to cause heat loss or much less often heat uptake. So sitting in front of a fan, sitting in front of a nice window with a breeze blowing over us, that's a way to lose heat through convection. There's also evaporation, only loss there. We have water on our surface, and the heat in our body causes the water molecules to vibrate faster. Some of them are lost, and as they are lost, they take a certain amount of heat with them. So that's how evaporation affects temperature. And there's also conduction here. So you may have occasionally seen a squirrel laying out on a rock or laying out on the pavement. Well, what days does that happen on? Most of you have probably seen that on warmer days. And that's when the squirrel is trying to cool themselves off through conduction with a cooler surface. Putting an ice pack on the head is another method of conduction where the temperature comes through that. Now, important in physiology is also the metabolic activity that is going to give us more heat. So that's endothermy, requires a certain amount of metabolic activity to generate internal heat. And should an individual have a fever, this is usually when the individual actually increases their metabolism so that they may increase their overall body temperature. All right, so what about outside? Microclimate. So this is going to be a bit of an activity and a video. So microclimate, observe in the following some examples of aspect and vegetation in my yard. Summertime and the grass is turning brown. This is the part of my lawn most exposed to the sun, the west side of my lawn, where we can expect the grass to begin to brown as it senesces, as the high temperatures push it towards its seasonal death. However, under these trees, well, shrubs, you can see the grass is still nice and green because of the amount of shade they get. This is one way that shade can influence microclimate. The temperature beneath these shrubs is a lot lower during the daytime. We have here a rhododendron plant on the northwest side of my house that gets sunlight pretty much half the day or more with the hotter portion of the day. This rhododendron is going to get a lot more sun, and as you see, it's a lot less healthy than on the other side of our driveway. This beast of a rhododendron. This is on the northeast side, so it gets the morning sunlight more than the afternoon sunlight, which is cooler portion of the day. So temperature is being affected by what portion of the yard east or west it's on. Also, it is under the shade of a Douglas fir tree right there, which allows it to have a lower daily temperature. So this is how temperature has been affecting the grass and has been affecting these rhododendrons through shadows and through what part of the through aspect, what part of the yard east or west it is on. As we may have seen, there's not really an altitude change, but there is a change in aspect. So I'm going to list these. If you attended class and you're watching this for review, this will be a good review. If you are doing this asynchronously, what I want you to do is I want you to pick one, and then I want you to post on the Moodle forum that will be hopefully up by then, a little bit about this component of microclimate and temperature. Don't just copy Wikipedia. I want you to put it in your own words. I respect you enough to want to hear what you have to say. So I'm just going to list these. You got altitude, aspect. You see the east and west in my yard. Vegetation. The vegetation with the trees, shrubs. And then the ground color. This would have been a simpler one if I had shown the road, which is black, is going to be hotter than the driveway, which is white. Ground cover, the vegetation also, the driveway, which is stone, is going to be a higher temperature than the yard, which is grass. So there's another effect of vegetation there. Boulders or burrows. And riparian effects. These last two are probably the best if you want to post up on Moodle. These last two have the most on them. All right, evolutionary trade-offs vis-a-vis temperature. So first off, let's discuss allocation. An organism has a limited amount of resources. Given that limited amount of resources, they can apply it to two different things. An organism can grow in size, they can forage or move around, or they can reproduce. An organism using its energy to reproduce is doing so at a cost of less resources that can be put towards foraging. An organism that is growing in size is doing so at a cost of being able to reproduce more. The idea behind allocation is that the limited amount of resources can only be allocated to a certain set of different conditions. So in physiological time, these different conditions may not just be grow, forage, or reproduce, but may be a bunch of different functions that the organism has, such as defending itself against predators, putting out new flowers, such. In evolutionary time, there's a trade-off between the ability to function well at one temperature or a set of conditions and function well at another temperature or a set of conditions, often related to the enzymes. Having an enzyme that works best at 40 degrees means that the enzyme that works best at 40 degrees can't work best also at 20 degrees. You can't have an enzyme working best, bester, and bestest at 3 degrees because those two of those aren't words. So there can only be one optimal temperature for an enzyme. Of course, there can also be the organism having two enzymes, one at 40 degrees that works well and one at 20 degrees that works very well, but that's twice the cost. The organism can also have regulatory proteins where the enzyme works best at 40 degrees until a chaperone protein changes the optimal temperature of that enzyme. So that regulatory protein, though, also is a cost that has to be produced. Or the organism can have inducible genes, where if it senses that it is 40 degrees, it produces enzyme A. If it senses that it is 20 degrees, it produces enzyme B. But there's a time lag there. There's always this one cost or another. Sometimes there aren't costs. The theory of allocation says there's always costs. Don't always believe it. Optimal temperature. This is just basic enzymes. If you have taken or plan to take biochemistry, then this is either review or preview. Below the optimal temperature, there is less function. Above the optimal temperature, there is more denaturing. Okay, cool. An organism that maintains itself at a climate where the outside temperature matches the inside optimum temperature for enzymes, that's an ectothermic organism. It does not need to maintain metabolism to heat or cool its body to the optimal temperature because it can just be at the same temperature as its environment. And in the equator, there's not much change in temperature from morning to evening, and there's not much change in temperature from summer to winter. And this is why so many ectothermic organisms live near the equator. So many lizards, snakes, fish can survive best near the equator because the outside temperature is roughly equal to the optimal inside temperature. Cool. Endothermy is expensive. So why do endotherms exist? Why can't all organisms just be at the proper temperature for their environment? Why don't polar bears just, have an optimal temperature of, 0 degrees Celsius? Well, seasons. Seasonality gives an advantage to the endotherm. So the garter snake that is able to function optimally during the summer season in the Pacific Northwest has to hibernate during the winter. So the wolverine that can function well because it spends its energy and invests its energy into maintaining a certain temperature, it can function well in the summer when the garter snake might be able to outrun it, but it can function well during the winter when all it has to do is dig up the garter snake and eat it as it sleeps. terrifying for the ectotherm, but a good example of an advantage for the endotherm. But it comes at a price. Organisms shiver during the winter if they are endotherms because they have to maintain that body temperature. I'm actually watching right now an endotherm hard at work. I'm watching a hummingbird pollinating outside my window. Now, in order to maintain its temperature, it has to consume a lot of nectar. I also have some bees that have been around my house today. They're ectotherms. They don't have to invest the energy in that temperature, but they also fall asleep when it's cold out. So I actually collected bees this morning in my garden that were just sleeping while the hummingbird flitted back and forth and watched me, because it can wake up early in the morning and the early bird, the endotherm, gets the nectar. Lizards. Let's discuss some evolution. If you're watching this for review, and you can probably tune out by now. If you're watching this asynchronously, this is the activity we're doing in class, is looking at how to introduce a lizard to a new environment. So you take this lizard. This is a western fence lizard. It does very well here in the Pacific Northwest with some seasons. It kind of hibernates during the winter. It's very active during the summer. What I want you to do is I want you to take that lizard at your choice. You can put it in the desert. You can put it in the tundra. You can put it on mountains. You can put it in the jungle. Pick a good place for your lizard. But I want you to relate any physiological changes that may go on that would make it more able to survive in your new climate. So although we won't be presenting your lizard to the class personally, if you're watching this asynchronously, please present your lizard to the class by posting it on the appropriate Moodle forum. Draw a picture of your lizard. I actually really like seeing the pictures of lizards. Like, this is a high point of the semester, an early high point. There are later ones too. Take a picture of your lizard and tell me more about it. Don't just take a picture of a Komodo dragon and say, my lizard, big. No, make your own lizard. So change how it gets radiation, convection, evaporation, conduction. Maybe its behavior changes. It hides in burrows, something like that. Tell me about your lizard, what habitat it is, and what adaptations it has. Then, move it to a different environment. This is after you've done your lizard, so pause, come back. I want you to think about how that lizard would not do well in a different environment, because limitations placed on physiology mean that it can only do well under a certain set of conditions. The trade-offs will necessarily occur that make a lizard less able to survive in a different habitat. And it's an evolutionary thing there. So this is an iguana. In Florida, they're an invasive species. They do very well in warm temperatures, but they cannot survive during freezes. So during a hard freeze, these lizards will literally drop out of the trees because they do not have the ability to survive during very cold temperatures, because in their native habitat, they don't need to. So this is an effect of, well, Florida. It gets cold enough to kill an iguana, but not cold enough to kill an eastern fence lizard, because eastern fence lizards will do just fine in Florida. They're native there. They can survive a freeze by just going dormant and hiding somewhere. Some lizards and some frogs are actually capable of freezing their whole bodies and then thawing out later. There are some cool adaptations to this, but they always come at a cost of being better in a different environment.